Good morning, good afternoon. My name is Alejandro Saucedo. I'm the Chief Scientist of the Institute for Ethical AI and Machine Learning. Today I'm going to be talking to you about the state of machine learning operations in 2019. I'm going to be covering a high-level overview of the ecosystem. So I'm going to try to go through several topics within 10 minutes. You'll have several reading material that you can access to check more. So to get started, the motivations is to give an overview of data science projects and more specifically the small ones. When you have the traditional sort of data science workflows where you get data, you clean it, select some features, iterate, and build your model. Once you're happy, you can put it in production, perhaps wrap it on a Flask service, perhaps just do a very simple web app around it. It works relatively well. There's not that many problems. However, as the data science team grows and the requirements grow, there's an increasing complexity of the flow of the data. Each data scientist wants to use their own tools. They have their favorite languages. Serving models becomes increasingly harder. And also when stuff goes wrong, it's really harder to trace it back. As your technical function grows, also should your infrastructure. And this is why it's challenging, because we're dealing with the intersection of data science, software engineering, and DevOps, creating this intersection of machine learning engineering, bringing best practices from each field. And that's why we created a curated list of libraries to deploy, version, monitor, and scale your machine learning. We're not going to have time to cover the entire list, which focuses on our 8 principles for responsible machine learning. But what we're going to cover today is 3 principles: responsibility, orchestration, and explainability. So the first one focuses, very similar to what was discussed in the previous speaker, on the data and model provenance and versioning of them. And this often is explained as the abstraction of the pipeline on its computational steps. And this is primarily on separating them on the data that is coming in, the actual code and configuration, and then the data that is coming out. By abstracting this atomic step, it allows us to go even one level higher and have our entire pipeline or entire ETL pipeline abstracted in this sort of compliance perspective. And there are several libraries that are trying to tackle this challenge of reproducibility, running something in one environment, being able to get the same result in the other side. And some of the libraries to watch, they're not just the ones that I'm going to mention, but one includes data version control. It's a Git-like client that allows you to do version management of your data, code, and output so that you can actually track and version every single step. ModelDB, it takes it in a different step, a different approach. It actually allows you to track all of the inputs and outputs that your code generates, and then gives you a dashboard to be able to visualize the performance of all the models and all of the experiments that you've run. Finally, Pachyderm is a framework that allows you to actually build, as they call it, compliance machine learning pipelines. And this means that you can be able to store and version every single run of your inference pipeline. So if you have a machine learning model that is trained in production, every time that it runs, it would actually store everything that goes in and out. The second one is model orchestration, training and serving at scale. This involves computational resource allocation, which is hard because it's like building an operating system which is completely distributed and your resources are all your nodes. However, there's been a lot of really interesting areas which I'm going to delve. One of them, Algorithmia, this startup in the US, has a very interesting comparison of the usage of traditional servers versus their actual usage. And they actually show all of the unused space that they have by just having those servers at all times. By using elastic servers, you still have some inefficiencies, and by using serverless, it actually becomes more efficient. There was actually a very interesting paper that was published a few weeks ago that was taken with a lot of criticism in the serverless space, because that actually highlighted some of the downsides that right now serverless doesn't yet have. And I would recommend you to check it out. One of the things that I didn't mention is that you can access the slides on that corner on bit.ly/MLOps19. A few libraries to watch include Seldon, which does orchestration primarily on TensorFlow servers. The second one is MLLeap, which dives into the serialization of models. So it actually converts the trained models into JSON equivalents and then loads them back again and runs them across, I think it's three libraries. And the final one is Deep Detect, which covers a broader set of machine learning frameworks, and it builds a unified API to be able to interact with all of them for training and inference, which I recommend to check out. The last one is on explainability. This covers the challenge of explaining and understanding black box model situations. This requires going beyond the algorithms through not just the machine learning best practices, but through tools, process, and domain expertise. The way that we've often tackled it in a talk that we also link is through 3 main steps: data analysis, model analysis, and finally production monitoring. The data assessment includes things like class imbalances, assessment of protected features, understanding correlations. The model assessment is understanding feature importance, using model-specific methods. And the final one is the model production monitoring, which is assuming that as soon as you put a model in production, it has the danger of starting to diverge, whether it's because of the data changes or another reason. So it's important to set metrics up front to be able to monitor that. Some libraries to watch include LE5, Explain Like I'm 5, which has several tools to be able to open up models both from the NLP side, image, and tabular data. The second one is SHAP, which is a unified set of best practices that have been brought together and represented as shapely values. They have model-specific as well as model-agnostic approaches, and allows you to visualize in a neural network, for example, what are the areas of the network that influence most that result. And the last one is one that we're maintaining. It's called XAI, which allows you to analyze data sets as well as models and set metrics to monitor in production. All of them, all the links are set below. You can access them when looking at the presentation. And unfortunately, 10 minutes is definitely far from enough to be able to cover all of the challenges that you face, especially now with this intersection in machine learning. And that's why I recommend you to go check out some of the open source projects that are there. The list itself is open source, so if there is libraries that that are not currently there, please feel free to add them, and also jump in and contribute. The majority of the projects are open source, except the 2 ones in the bottom with the $signs, which are commercial. But there's some open core as well in the other ones, but I do recommend to check them out. And so with that said, managed to do it on time, which is I'm quite happy. And we have, I guess, time for one question. And thank you very much.